Hello and welcome to the 7th section, Shipping and Deploying. In the previous section, we learned how to test our applications. In this section, we will learn how to package your applications and deploy them on the cloud. First, we learn what is dependency hell, what is semantic versioning, and why use it. We will learn what is package.json file, how to create it, and what's inside it. Then we will understand what is npm, how to prepare the package for publishing, and how to publish to npm. We will learn what is platform as a service, what is Heroku and how it works. And last but not least, we will see how to install Heroku Toolbelt, how to deploy an application, and how to configure it. Now we move on to the first video of this section that deals with dependencies and SemVer. When making a web application, you will be using a lot of packages written by other people. You will do this to avoid having to write everything yourself. The bigger your application grows, the more packages it will use. The more packages you use, the higher is the chance to end up in dependency hell. Dependency hell is a term used when versions of packages used to conflict and makes it harder for you to proceed with building your application. You have to be careful with managing your dependencies. If you make the constraints too tight on the dependency, you might not be able to update it, or it will constantly require input from you to update. If you make the constraints too loose on the dependency, there is a high chance that a change in the dependency could break your application. Semantic versioning, or SemVer, is a set of rules and requirements that dictate how version numbers are assigned and incremented. They are based on widespread common practices and better defines that you could expect from the dependency. The rules have keywords must not, required, shall not, should not, recommended, may, and optional, to better define those rules. There is 11 rules, and we will learn the most important parts about them. The software that uses semantic versioning must declare a public API. This API could be in the code or in separate documentation. The normal version number must take the form of x.y.z. The x, y, z are non-negative integers without leading zeros. X is the major version. Y is the minor version. Z is the patch version. Each element must increase numerically. Once the version package is released, it must not be modified, and all modifications should be released with a new version. Major version of 0, 0.y.z, is for initial development. The public API should be considered unstable and could change at any time. After the stable version is released, 1.0.0, the version number changes depending on the changes made to public API. Patch version Z must be incremented if only a backwards compatible bug fixes are introduced. Bug fix is an internal change that fixes incorrect behavior. Minor version Y must be incremented if new backwards compatible functionality is introduced. Patch version must be set to 0 when minor version is incremented. Major version X must be incremented if any backwards incompatible changes are introduced. Patch and minor version numbers must be reset to 0 when major version is incremented. Semantic versioning allows the dependency to better communicate its intentions. If application is very important, the developer can choose to use the exact version of the dependency or only update to bug fixes. If the application is not that important, the developer can choose to make the requirements looser and make the maintenance of the application simpler. Check the SemVer.org if you want to learn more about it. In this video, we learned what is dependency hell, what is semantic versioning and why use it.